3D printers are changing the way we build just about everything, from our cars to our homes, even our food. But can they recreate one of the most crucial and complex human organs?
It sounds ambitious, it is ambitious, but we believe that a lot of the basic building blocks to go ahead and start a project like this are in place.
Dr. Mark Schuyler Scott and his team of bioengineers are using advanced 3D printing techniques to turn a paste made of living cells into actual heart tissue. The goal? To one day be able to print crucial pieces of the heart, like valves and ventricles, that are living and can actually grow with a patient.
For adults, we have donor organs that can last 20, 30 years after transplantation, which if you're a 60 or 70-year-old adult is almost as good as a cure. But if you're a child at the age of 2 needing a transplant, knowing that after 20, 30 years your transplant may be rejected by an immune reaction, then this is not long enough.
The concept of printing living tissue isn't new. It's called bioprinting, but it can be a slow process.
If you truly want to recapitulate everything about an organ, one might think about the need to write every single cell in its final location. Now, if you did that at a rate of about 1,000 cells per second, it would take over 1,000 years to make a single heart.
And that's where Dr. Schuyler Scott's team made a breakthrough. They developed a way to print with clusters of thousands of cells called organoids.
We take millions of those aggregates and condense those into what is essentially like a human stem cell mayonnaise. And we can then print through the printer. We can write very large and thick slabs of tissue that can really be used for transplantation in the future.
Yes, he just said stem cell mayonnaise. And once it's printed, it takes on a general shape of tissue that they can print blood vessel networks into.
We have the ability to write tissue, living cells from stem cells, and be able to come in and pattern vascular channels in 3D, and then connect those channels to a pump and flow oxygen and nutrients through that tissue so it actually stays alive.
What you're seeing in these videos is that technique simulated for us with what the team described as essentially hair gel. The stem cells they use when they're printing a real sample are grown here in this large bioreactor. All those little things you see floating that look like bubbles are actual stem cells. So far, the team has been able to create a structure similar to a human vein, about 2 inches long and 0.5 centimeter in diameter, that could actually pump fluid on its own.